Good afternoon, everyone. It's good to be talking with you guys again. I have a little bit more time, and I have a new topic. So today I'm going to talk to you guys about federated search across multiple wikis using large language models and model context protocol services. It's okay if you don't know what that is. I really don't either, but I'll try to approach it at a high level and we'll figure it out together. So the outline of my talk is basically I'm going to give you an introduction to the environment that I'm in, the situation we have with regards to our enterprise wiki server. I'll describe the problem, and then I'll tell you about the solution in two parts, give you an update on our status with it, and tell you about what we hope our next steps to be. So kicking off with the introduction. This is a chart that you saw just a little bit ago. Just to orient everyone, I'm not speaking for the entire agency. I'm speaking for the Armstrong Test Facility in Sandusky, Ohio. The other locations represent different parts of NASA around the country. This is an aerial view of our campus in Sandusky. You can see Lake Erie in the background. The dotted line campus is roughly 10 square miles. The circles represent sites where we have large space and aerospace test facilities where we do ground-based testing of the extreme and harsh environments of space and aerospace. Our facilities, these are photographs that were taken inside some of our facilities. You can see the Orion crew module and service module shown on the left. This is what would be the payload at the top of the Space Launch System, which is part of the Artemis project, which is taking American astronauts back to the moon here shortly, we hope, in a couple of days. You can also see like the Dragon 2 capsule on the right in one of our other test facilities on top of the Falcon 9. So we've done like the Orion crew module testing, service module testing, payload fairing testing, and Dragon 2 capsule testing. That's the kind of stuff that we do. And our facility has historically used older tools we're trying to modernize. And so the wiki becomes, the MediaWiki gets introduced into this story by the fact that we're trying to do more with less. We're trying to be more efficient. We're trying to digitally transform, get away from the use of paper. We're trying to modernize our methods according to best practices. And we've been running a semantic MediaWiki application since around 2008, and it's building up more and more uses, and I'll tell you a little bit about that. So an obligatory slide, MediaWiki Core, which is MediaWiki software par excellence, combined with all of the third-party extensions, allows MediaWiki to transcend its normal classification of as a wiki into what I like to call like a business application platform where you can sort of do it yourself, build your own electronic workflows and applications, and I refer to that as MediaWiki Plus. The situation that we're in, this is a very busy chart, and I don't want you to spend too much time looking at the details, but what I'll try to show you is that NASA has something called ICAM. ICAM stands for Identity, Credential, and Access Management System. This is an agency-wide IT infrastructure for identity management and access management. The idea is that every IT asset at every level, everywhere in the agency, is using access control and identity management from a common federated source. So the way that it works is that this box represents whatever application you're interested in. What we'll talk about here is when this box happens to be a MediaWiki application, but it's literally everything. And across the agency, in all of the different field centers, there's all kinds of different software applications, and they all conform to this ICAM model. At the very top of the infrastructure, the agency runs an Active Directory, federated services in conjunction with, I think, Azure now. But the point is that we're, ADFS is where the identity layer across the entire agency. We have a special application for defining and managing the roles within our applications. So for application X, maybe you have view access, maybe you have edit access, maybe you're an administrator. These roles are managed at an agency level, and then they're consumed by the application. Similarly, we have an authentication, an identity provider at the agency level. And so the idea is that if I have a laptop, first of all, it can't be my own laptop. So this dotted line box represents the NASA network. And so this laptop would be an approved asset. So these are machines that are controlled. The configuration management of these machines is handled at an enterprise level. I'm not an admin on this machine. They push updates on it and they configuration manage it for me. It's equipped with a PIV badge reader. And so in order for me to even log into this system, I have to have a badge that contains my identity. Security is multi-factor authentication is two of three things. Something you have, something you know, or something you are. Something you are could be a fingerprint. Something that you know could be a password. Something that you have could be a badge. So what we've elected to do for multi-factor authentication is every NASA employee gets assigned a badge that contains their identity, and there's a password that goes with it. So the badge is something you have, the password is something that you know. You insert that into the laptop. That combination of things allows you to access the machine, and as soon as you log in, the machine now knows who you are as a user for accountability. So now when you go to access some application on the NASA network, it automatically shares your identity that you've logged in with, shares that identity with the authentication service. Depending on the application that you're trying to get access to, it checks with the authorization system. And the combination of once it knows who you are, it can figure out what you're allowed to do, and that combination of information is sent back to the browser and contained into a secure session and some tokens that the application is then required to consume in order to decide how to proceed. So that's the basic model. Identity management, credential management, and access management all bundled into one overarching program. So then what does this look like if this happens to be a MediaWiki application? Well, it's a little busy, but we've got the MediaWiki core up here, and the two big blocks that I'm showing in here is the extension pluggable auth, which is kind of a general framework for interfacing MediaWiki's credential and user registration system with other types of identity integration. And then we happen to use simple SAML PHP currently as our way to get both authorization and authentication. So when the user sits at their computer with their badge installed and they're logged in and they visit the wiki URL on the NASA network, they get a secure session token, which the wiki is then able to consume the attributes of the token in order to understand and what we call auto provision. So whether or not the user, the wikis are all private, and it's not just about being a registered user, it's about being a registered user in the wiki who is a member of a specific custom group, and the membership of that group is defined by the SAML integration, which is received from the ICAM system above. Down below, we have our operating system, file system. We have the MySQL engine, the Elasticsearch components. Each of those has their own data store. If we're running a wiki farm, which we are, and we have something like 20 plus wikis on our application, then you multiply all of these things times 20. On the front end, we've got an HA proxy reverse proxy SSL terminator that basically just provides the secure data in transit, and then all of these components operating on the back end are protected, or they're operating behind that proxy. And so the Apache and MySQL and Elasticsearch can all interact with each other privately on the local host without having to securely interact with each other. And so it's only the interactions through the front end that have to be handled securely. I included this just because if it comes up, somebody might want to know In order to configure the simple SAML PHP, you basically have to define what the entity ID is, give it a name ID policy, and then what the application is that's trying to request the identity and what the identity provider URL. So this is basically send and receive, who I am and where I'm going to find out who the user is and what they can do. And then once we've configured that, we can come down here to the SAML 20 IDP remote and tell it the callbacks for logging in and logging out. And then there's the cert data where I've truncated that. So that was the simple SAML service configuration outside of the MediaWiki application. If we go back to our model here, you can see that that's represented by this block right here. Now on the MediaWiki side, we have to configure pluggable auth and simple SAML PHP, the extension, not the service. And I've highlighted a few of the items in that configuration. This is all very general stuff, nothing sensitive. If you were trying to replicate this kind of a configuration, then this is available. Feel free to borrow what you see here. And lastly, you have to go into local settings, and you have to tell, this is the authorization piece. Everything that I've shown here is pretty much authentication, figuring out who the user is, and then this is the part where we configure local settings to consume those role attributes and figure out how the user is actually going to, what rights they have within the system. Okay, so having done all that for the different wikis, so this is what our landing page for our server looks like. If you're on the NASA network and you go to wiki.grc.nasa.gov, this is what pulls up. This is the landing page for the Mesa system. Each of these icons represents a different wiki with a different database and a different file store on the back end, but they're all configured the same in terms of the extensions. They do have different SAML integrations, and so what that means is that a user might have access to this wiki, and this wiki, but they might not have access to these down here. The point is that the ability to view, to get into any of these wikis is determined by that ICAM roles management system at the agency level. So when you visit one of the wikis, it sends you to the IDP, which is our Launchpad service. This is the system that works with your local laptop asset, figures out who you are, and then returns, if you're approved, returns the secure session token, and then it lets you into the main page of whatever wiki you were trying to access. It all works very nice. Each of these wikis has a lot of really great individual content for the different test projects that we do, the different facilities that we operate. There's all these different reasons why we operate different wikis because they all have different access control schemes. So the problem now is that if somebody wants to find something, we do not have the ability to search all the wikis with one search input box. So what that means is, and you can see what I've done is I've sort of replicated the search results. This has to be done times 20. So each one of these wikis has its own search, has its own little search feature bar. And if you're trying to find my file.pdf, you have to, currently you have to either know where it is, and if you don't know where it is, you have to sort of systematically go and look through each wiki, which is obviously not ideal, but it's secure. If you are denied, if you are the kind of user who is only authorized to see the wikis that are not grayed out, then you'll get those results from those wikis. But if you try to search one of the wikis that's been grayed out, indicating that you're not an authorized user, you get an access denied screen, and that's the end of the story. Not very ideal, but it is secure. So that's the problem, is the absence of federated search. So the solution is in two parts. Part one is the ability to find a way to do federated search, and then part two is to do a restricted, what do I have it phrased there? Access constrained search results. So what I'll show you is that in part one, it's very straightforward to use a large language model to use an MCP service, which exists, configure it so that when the user says, where's my file, the LLM chat system can be pre-programmed to search all the wikis, and if all of the wikis were open access, that would be the end of the story. So where the problem gets more complicated is in the second part, where we're going to have to do access constrained search results. So fortunately, I don't have to build an LLM chat service. Somewhere in the past 2 years, the agency decided, to their credit, it would be a really great idea if some IT organization somewhere in the agency set up their own internal NASA-approved LLM chat service. This is particularly nice because it allows you, it's not one model, but there's a pull-down menu at the top where you can actually choose the model you want for whatever purpose. So it's a really diverse solution. I've copied some of the the high-level descriptions of what it is and why it's good. This comes right off of the application main page for learning about it. But basically, this service is running at the Goddard Space Flight Center, I believe in Maryland, and we are in Ohio. But no worries, this system uses the same ICAM agency service that my system uses. So that when I visit this site, it knows who I am for the same reason that the wiki knows who I am. And so that means that there's some goodness here where the two systems are understanding the same identity. This is just I won't dwell on this much, but this is a diagram that I got from their charts for the chat service, where the NASA employees are interacting with a load balancer, similar to the way that when users visit our MediaWiki site, they're really hitting the HA proxy front end. And then behind the proxy, you have your document database, vector database, the RAG model, the chat user interface. This is the basic chat GSFC application. And then on the back end of that, you've got your LLM API portal, where it reaches out to the different LLM models that you can select from. And then in the vector database, there's also this option to tie the response, the RAG response, into a variety of MCP services. And I'm not an MCP, I'm not an LLM expert, and I'm not an MCP expert, but what I can tell you is that the LLM is there and it's available for us. And if you go out to Professional Wiki has very kindly, for the community, developed the MediaWiki MCP server, which it's open source. And I've already talked with the folks at the Chat GSFC service, and we're actively working on an integration of the MediaWiki MCP service with the Chat GSFC LLM. And when we're done, what we're going to be able to do is program the Chat GSF service through the MCP on the back end configuration, so that if I say, where is my file in the ATF knowledge management system, it will know to go search all these wikis, compile all the results, and do a RAG response to the user. And so it's the federated search function. This is actually, so you can see that, rather than the user trying to visit the wikis directly, the user hits the LLM interface, asks what they're looking for, and the LLM searches the entire ensemble, the entire wiki farm for what they're looking for. And if every user had access to every wiki, we'd be done. So the next part of the challenge in the solution part 2 is access constrained search results using IDP scopes and OAuth 2 delegated tokens. This is just, I'm bringing you back to this chart just as a reference. This is the problem we're trying to solve. So Simple SAML PHP is a PHP library that implements the SAML 2.0 protocol. It's a bridge between a web application and an identity provider. It is exactly what I described it to be. It is nothing else. So the takeaway here is that it was never designed, the SAML protocol was never designed to provide delegated authority that could be, where you could give a token to another agent and let that agent operate on your behalf with your authentication token. So SAML simply doesn't have what it takes to implement this solution. Enter OAuth 2 with OID Connect, pardon? OpenID Connect. And so OIDC was created for the exact problem that we're trying to solve. And that's incredibly good news for us because that gives us our path forward. So now if we come back to our model, we can now eliminate the simple SAML service from our tech stack. We can keep pluggable auth because that's the core authentication and authorization extension for MediaWiki, but swap out the simple SAML connector and replace it with the OpenID Connect. But what that means is we have to ditch our Active Directory connector, and so now we're back up into the Azure Active Directory and Entra, and we have to work with that team that handles those kinds of application registrations at that level. And we're in the process of doing that right now, getting a little bit ahead of myself. And so here we have the same basic model, but this time with where the chat GSFC has delegated authority. So the user with their badge has multi-factor authentication to securely access the NASA laptop or asset. That asset on the NASA network can access the NASA chat system, the chat model. The chat model has the MCP service configured with the ability to take this identity provider is now an OIDC configured so that it can provide tokens that can be delegated to this application, which now this application can try to access these wikis with the authority that the original user has. And what the effect that has is that if the user says, "Where are my files?" the system will get access denied and ignore those sites, or even report back and say, I couldn't find your file, but hey, it looks like I wasn't able to check all the sites. And so we'll be able to fine-tune those kinds of responses. So on the right-hand side, you see MediaWiki MCP call to the MediaWiki APIs, and then we have the MediaWiki API responses to the large language model, which provides the RAG result to the user in the LLM interface. Our status? Mainly just lots of design, planning, and paperwork, but that's actually 90% of it. We're pretty close. So what we've done to date, we did the technical and feasibility study. We got endorsement from the Chief AI Office, GSFC. We got endorsement from the data center where our wiki application is hosted. These are big milestones. We got endorsement from the Office of the Chief Information Officer and the CIO for the agency, the folks that run the ICAM service. We've done the development of an interconnect security agreement, which is basically a document that describes everything that I've presented to you today in a little bit more technical detail, so that rather than just building the system and enjoying it, we actually have it's a documented interconnect agreement between two separately managed systems. We're currently working on building up a development wiki or upgrading our development wiki to switch from SAML to OAuth 2, IDP, and OpenID Connect. And then we're also getting ready to build up an LLM test system that will not be very well powered. It'll be just functional enough to prove the point. I have a chart here. I won't spend any time on it, but this is basically the architecture of the LLM test server that we want to build, and some of the open source tools that we're using and how they would be implemented. And lastly, our next steps is build up the test server with the OAuth delegated authority using the MediaWiki MCP service provided by Professional Wiki. Do that for the ATF Wiki server, test our secure functionality, and then apply for authorization to operate in production. And we're hoping to do this for the benefit of the agency.
All right, thank you. That was great. I'll just say that, so with OpenID Connect, it will give you access to the tokens, but if it turns out you need any customizations, you know I'm always here for you.
Absolutely.
So Jeffrey, hold on one second, question.
All right, so in the state of Oregon, psychedelic mushrooms are legal and highly regulated for therapeutic purposes only. As you know, that's the only state in the US that probably has legalized psychedelic mushrooms, and they're the only ones who can help with that therapy. As a Washington state resident, I can travel to Oregon to make use of those services. So it's basically, is the Goddard Space Flight Center essentially Oregon in this case? And I'm not just trying to talk about drugs.
Yeah.
Is that the relationship that you have with Chat GSFC and your use?
No. It's a wonderful question. You did ask it on the microphone, so I don't have to repeat it. Let me walk back to the last chart that I have. There it is. So this Entra, basically, in order for a user to access the wiki application, there has to be a registration of the application in Entra. In order for a user to access the Chat GSFC, there has to be a registration in Entra for Chat GSFC. Within Entra, it has the ability to say that the Chat GSFC scope requires the MediaWiki roles. And I don't think that I'm saying that entirely precisely, but the point of I think the answer to your question is that we're not relying on the on the Goddard LLM application configuration to dictate who has access. What we are saying is that when a user accesses the Goddard language model, part of the roles that model knows is the roles for the wiki. And that's an ephemeral thing.
It trusts what you tell it.
No.
It trusts
What Entra tells it.
Okay.
So what's not shown in any of these diagrams is the detail within Entra. So both applications have to have a registration, a separate registration in Entra, but the OIDC capability allows you to configure the two registrations to share information with each other. So the authority is validated. So Entra provides the token that the language model, let me see if I can, Entra provides the token that the language model attempts to search the wikis from. But that token came from Entra.
So Entra is centralized and NASA's not federated.
Correct.
Okay.
Yeah. And so that goes back to the original chart. Where I was just introducing the ICAM. So this block up here is agency-wide. Okay. All applications, let's do it one more time. You know what, let me I apologize for skipping through the charts here, but I think it'll help. So I didn't spend any time on this. There it is. So this is the map of the nation that shows where all the NASA centers are. And what I've highlighted here is that down in Marshall is the ICAM service. And over here at Goddard in Maryland is the Chat GSFC. And here in Ohio is the wiki application. So today, regardless of this chat interface, when users sitting at terminals in Ohio try to access the wiki in Ohio, they get authenticated from the ICAM service at Marshall. And when users sitting in Maryland try to touch the language model, the Chat GSFC, they get authenticated by the ICAM service at Marshall. And so what we're building is basically a distributed authentication system across the agency. Did that answer your question?
Yeah, this is really fun for me.
Okay. Any other questions? Mark.
Live mic? Looks like no. Okay.
No.
Just just for curiosity's sake, if an employee wants to search within a single wiki, knowing that that is the target wiki, but wants the benefit of the LLM engine and everything, is this designed for, or will it be designed to where they can choose their facets?
Absolutely. Yeah, and you would just do that at the prompt, at the LLM prompt. Just say, hey, you know, go into wiki X and verify that my file is there.
Okay.
And yeah, so one of the nice things about the chat system is that it will let you ask to search 1, 3, all, right? You can specify where you want to look for things.
Sure.
But what's intrinsic to this whole architecture is that we're not hard coding it to have access to everything, and we're not, you know, that the access control is not at the application level. Access control remains where it belongs at the ICAM level. Okay.
Cool.
Any other questions? Or
You just have from the comments from Jared Olson, a previous NASA employee, lots of parts and so cool.
cool. All right. Thank you so much, everyone.